Organic chemistry is something that you talked about a little bit in biology. We're going to kind of just scratch the surface. Organic chemistry is something that you can actually spend multiple classes in college talking about. It can be quite complex. So we're just going to be taking kind of a basic look at it rather than a super in-depth look. So organic naming is very similar to covalent in that there's some prefixes that we need to use. Once you hit 5, the prefixes are identical to those in covalent naming. So for 5, it would be pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. So we don't use those extra vowels like we do in covalent, but other than that, those are all the same. 1 through 4 has its own unique set of prefixes. 1 is meth. Yes, meth. 2 is eth. So it's meth without the M. After 2, we have 3, which is prop. Prop, you probably heard these prefixes in things like propane if you have a gas grill, or isopropyl alcohol, which is rubbing alcohol, or ethanol. All of these things you've heard these prefixes, you just haven't associated them with this. 4 is actually bute, but it's spelled like butt. It is bute, like beautiful. That's how it's pronounced. Granted, you will never have to, pronounce these as part of an assessment, but just know 4 is bute. So what do these prefixes represent? Well, they represent the number of carbon there are in the compound. So if we take a look at this example, the first part of naming any organic compound is counting the quantity of carbons that are there. So this molecule has 1, 2, 3, 4, 5, 6 carbons. So it's going to use the prefix hex. The second part we're going to talk about in just a moment, but to start off, you always count the quantity. As I said, organic chemistry is quite complex. We're only going to be taking a look at 5 types of compounds. There are many, many more. These are the 5 most common compounds that we're going to take a look at. So the first is an alkane. So the thing with the types of compounds is they have an ending that we associate with the prefix and combine them in order to make the name of our chemical compound. So in this first one, an alkane, it has an ANE ending. So this is an example of an alkane. So we would count how many carbons there are, which in this case there's 3. So we would use the prefix prop and then the suffix ane. So this is actually propane. So propane gas, if you've ever bought it, that's the chemical formula for it. So there's a few things that I'd like to point out here. Notice how we only have carbons and hydrogens here. That's as a result of that makes this a nonpolar substance. So nonpolar, we haven't explicitly discussed this year yet, but you discussed it in biology. It's where electrons are shared equally throughout the entire compound. So this is an example of it. This is also an example of a saturated compound. So what we're referring to with saturated is that it's essentially all single bonds in this organic compound. So we have carbons and hydrogens all singly bonded together. We don't have any double or triple bonds. So this is related to saturated fats. Saturated fats, fats are extremely long carbon chains and combinations of carbon chains, but they're very long, and what ends up happening is when they're saturated, they're all single bonds. So saturated fats are the fats that are referred to as bad fats, and that has to do with when it becomes cholesterol in your body. The saturated fats make very long carbon chains, which are referred to as low-density lipids in your blood, which can potentially block artery if there's a lot of them. It generally happens as people get older. So those were alkanes. We also have alkenes. So we now have an ENE ending. And what an alkene is, if you notice, if you look at the difference here between the alkane and the alkene has a double bond. You might be thinking, well, how do I know where the double bond goes? Well, for us, we just need to make sure it's between two carbons. We can't have the double bond anywhere else, otherwise it won't, the bonding won't work out quite right. So it's a double bond. So this is referred to as an unsaturated substance or an unsaturated. Hydrocarbon is a kind of generic term we use to describe organic compounds because they have hydrogens and carbons in them. So this has a double bond. It's also nonpolar. So nonpolar, again, the electrons are being shared pretty equally throughout. So again, this one still has 3 carbons, so it uses the prefix prop. And now we have the ENE, so it becomes propene. So we have propane, propene, just like we have alkanes and alkenes. Next up, we have alkynes. The Y kind of makes an I sound. I'm going to put an I in parentheses there. It's an alkyne. Otherwise, it would sound exactly the same as alkenes. So this has a YNE ending. So again, it's pronounced ein rather than een. So again, another example with the 3 carbons, we would make this the prefix prop. So then this would be propyne. Still nonpolar. This is also unsaturated. And the reason this is unsaturated is because of either the double or the triple bond. Double or triple bonds make your organic compounds unsaturated, and we end up, and this has the triple bond in it. These are the 3 main types. The last 2 are kind of subtypes. The first group we have is an alcohol. Alcohol is a generic term. Alcohols have the ending OL. So alcohols have a range. They can be polar to slightly polar. So polar to slightly nonpolar. With polarity, there's kind of a range. It's not just polar and nonpolar. Depending upon several factors will determine exactly how polar. For us, with organic chemistry here, it depends on the carbon length. So if you have a shorter carbon chain, so let's say you had like 3 carbons with the OH on the end, which is what makes it the alcohol, it would be very polar. But if you have like 25 carbons with the hydroxide group on the end, it's going to be slightly nonpolar. So it depends how long your carbon chain is. So there is a bit more of a range here. And what makes this an alcohol is that OH group. So right here, I'm going to circle it. Again, I'm not real concerned about placement here. We're more interested in kind of identifying. When you see that OH, that's indicating it's an alcohol. It gives it an OL ending. So there is a little bit of another part to this. So we have prop, which comes from the 3 carbons. We do have to take a look at the remaining carbons to see if there are any, if it's all single bonds, if there's a double bond or a triple bond. So there's all single bonds, so it has the N, which comes from the alkene. And then the last part is the alcohol. So this is propanol. The AN comes from being an alkane. The OL is what tells us it's an alcohol. So there's kind of 2 parts to it. And then the last one is a carboxylic acid. The last type that we're going to discuss for us, which again there's many more organic compounds out there, is a carboxylic acid. The ending here is OIC and then acid. If you think back to acid nomenclature, the ic ending here is very similar to what we use for if we have like hydrochloric acid or carbonic acid. It has that IC ending. We just have the O as well here. It follows a similar pattern as the alcohol. So we have 3 carbons. It gives us the prop prefix. We take a look at all the other carbons. They're all single bonds, so it's most similar to an alkane. So it becomes AN. And then the last part here is our carboxylic acid component, which is what makes it OIC. So this is propanoic acid. So you'll notice in the carboxylic acid we still have the hydroxide, but we also have this carbon with a double bonded oxygen. You've seen these in biology and also in AP biology, but the big thing here is that you have this carboxylic acid group, which is sometimes referred to as COOH. That's what makes it a carboxylic acid. So it's not just a hydroxide, it's a hydroxide plus another oxygen. The other thing here is that this ranges again from polar to slightly nonpolar, depending upon how long the carbon chain is. So if you have like 5 carbons or 2 carbons, it's probably going to be polar. If you have a lot of carbons, if you have 30 carbons or even 20 carbons, it's going to be slightly nonpolar. So what makes these polar are actually the circled groups here. The oxygen is what makes it polar here, and when we talk about polarity, we're going to talk about why oxygen does that. It has to do with the electronegativity of oxygen. Oxygen is very electronegative. You can actually have nitrogen groups attached to these organic compounds as well, and it also would make it polar, but we aren't going to discuss those. In your body, though, you have a lot of functions that use nitrogen as well as